Welcome to the session, Management and Governance in the Cloud. My name is MaSonya Scott, and I am a Principal Specialist and Service Management Connector Product Manager at AWS. I have over 22 years of professional IT operational experience. I started with supporting applications and evolved to consulting and implementing IT transformation programs for large enterprise customers. Now, by the end of this session, you should be able to articulate the importance of cloud operations, understand AWS Management and Governance Services value proposition to cloud workloads, and evaluate a cloud operations interoperable solution that integrates ITSM tooling to AWS native services. Let's start the session really quickly with a scaling use case. Now, how does a coffee shop chain scale? Many of you have a specific coffee chain that you can visit in your country or even globally to get your perfect coffee and expect the same taste and flavor regardless of where you are, right? This is achieved through developing consistent experiences, having the same look and feel in menu choices, and more importantly, operational procedures. Thus, it is important to create standards, best practices to scale your business. And that's that, right? Coffee product standards can also translate to IT services. Whether it's getting that consumable product taste, having the same type of menu, giving the ability for your consumers to request that product through various mechanisms, whether it's through mobile or drive-through or even in person, having the same specific standards for your coffee, making sure your coffee is in stock. And if it's not, addressing that through your inventory management processes. And then having your operational procedures to make sure those are functioning without your store, and having standards across all of your chain shops so that customers can have that same experience no matter where they go. This is no different if you translate a consumer product such as coffee over to a IT service, which is also a product for end users and stakeholders within the business, right? So whether it's self-service provisioning, requesting for resources that you need to do the tasks that you need to do, inventory management or detective controls to make sure that resources, the life cycle of those resources is tracked, managed, and addresses non-compliance, ticketing management or cases. Making sure from an incident management perspective that you're restoring service at the right point in time, having the necessary procedures to remediate and ensure customer satisfaction in the services that you provide, and then addressing interoperable solutions that bridge between different product integrations that you may have within your organization, right? So I've stated that you needed to account for operations. It's at the title of this slide. And I assume that your question back to me is, well, how should I address cloud operations? Addressing cloud operations means that you understand the intersection of people, operational processes, and toolings that support your cloud workloads. Cloud ops also includes identifying stakeholder and technical dependencies, and finally understanding who is going to support your cloud workloads. Your team should know who they need to call at 3 o'clock a.m. The answer is not Ghostbusters, by the way. Ode to the movie. In addition to your support model, you need to design your cloud workloads with operations in mind. Establish IT service metrics, including service level objectives, to meet your stakeholders' consumption of your services. And then always continually improve those services by evaluating the performance of your services against those service targets and embedding mechanisms to constantly iterate and improve those services. Whether AWS services are maintained or refreshed, customers, especially enterprise customers, have an operational engine that addresses controls, interoperability, reliability, accountability, and transparency for IT services. Oh, and don't forget to include mechanisms to manage costs by developing tagging strategies that enable you to identify ownership of those resources. Adopting the use of templates, infrastructure as code that enhance that reliability and predictability of your services. Setting the appropriate guardrails and giving you the governance within that playbook and that framework that people can have the ability to innovate. Enabling mechanisms, scripts, to turn off and spin up resources based on their usage in a given environment. And setting budgets and reports to notify you when services or accounts are meeting certain cost thresholds. And I cannot emphasize enough the importance of developing incentives for your engineers to iterate and improve workloads that improve those solutions and enable production readiness as well as save costs. At AWS, we have over 17 management tools in our console, including CloudWatch, CloudFormation, and CloudTrail. Whether it is establishing platform architecture via AWS Control Tower, enabling self-service preventative controls via AWS Service Catalog, or enabling resource transparency and detective controls via AWS Config. As our customers grow in their use of AWS, these services mentioned above become critical in establishing that right level of control over their environment without slowing down innovation. And so we've listened to our customers in the management and governance product suite space. And our customers agree that these native services align to cloud operations and cloud operations models that they have for their IT services. But their feedback is that they have too many tools, too many operational tools, whether it's monitoring, ticketing, testing, development pipelines. How can they create and leverage the native features that AWS has for management and governance in a federated view on tools that they tend to use to consolidate all of their service management health? And those tools are, for example, IT service management tools, which are industry standards aligning to the life cycle of services, right? So to address this, and we know that customers have, too many tools, multiple owners, limited resources to establish that right balance and agility. And so what we've taken action of doing is introducing the AWS Service Management Connectors for ServiceNow and Jira Service Management. And these connectors allow our ITSM end users to provision, manage, and operate AWS resources natively within their ITSM tooling, whether it's executing automation playbooks, requesting and provisioning IT services, resource transparency in a CMDB or asset repository view, or even managing operational items or security findings that translate over to incidents or problems based on the integration of native AWS services. These services simplify AWS products, actions, and management of services and provide ITSM tool governance and oversight over AWS native capabilities. The benefits of customers using service management connectors are the ability to reduce time to integrate to their ITSM tool system declared records tooling of choice, eliminates admins for ITSM toolings to have to ramp up on AWS services, and AWS cloud engineers having to ramp up on meeting customers where they are in their management of IT services, and gives that bridge for our customers to make sure that they can do native features from AWS in familiar tooling. So what I'd like to do now is go through an IT lifecycle management with AWS and JSM using the service management connector that we have on the JSM data center release. And so what this is going to do is show a product for an S3 bucket request being requested, being approved, provisioned, but then we're going to also detect through detective controls of AWS config that S3 bucket was unfortunately provisioned as a public bucket, and the company's policy is that they should be private. So we create an incident. We also create an incident that has an associated runbook to make that bucket private, and then we remediate that issue as a result of it. Okay, so let's go into this demo, shall we? All right, so you see I'm in the JSM or Jira Service Management portal, and I'm going to request a bucket, storage bucket S3, and with that, it'll tell me where that bucket lies. I'm going to, if I wanted to, I could put some product tags on this, and what I'm going to do is it was requested, and I show that as an issue of issue type AWS Service Catalog. And as you can see in the JSM platform, I've created an approval workflow to give an additional granulated governance mechanism. And so we've approved this particular product to be provisioned for the S3 bucket. And you can see that it's under change is launching. And this provision product workflow shows all the different steps that's needed, right? And the purpose of this illustration just walk through how embedding governance has that outcome of providing predictable, reliable resources for your environment. So it's in progress. You can see through AWS config in a tree relationship view, the details, what's it associated with, what's it contained in, what's it hosted on, and you can see those details from that point of view. And then if there were some existing tags, it would show those details as well. And so from there, what we're going to see shortly is that this product, after it's launching, once it's fully provisioned, it becomes in an available state, right? And through that availability, you can see that it's available. It has certain outputs, and we'll see that it shows the success of it. But back in AWS config, unbeknownst to the end user that requested it, a AWS config rule has detected that this bucket was non-compliant, right? Because it's public. So what we need to do is make this right. And what we've done is we've configured the connector to create incidents, and all of this detail of how to do this is through public documentation. And from this, what we see is based on that incident in JSM, we show the config resource that it's linked to. We show the suggested remediation action, which is to basically make it private, right? So we're going to execute that systems manager automation runbook. We're going to put in the necessary parameters. So for this one, it was the S3 bucket name. If we go into that remediation action for that automation document or runbook, as it's called today, we'll see that it's a success. And then once we go back into the console, and this is from the cloud engineering view, we'll also see that we no longer have any non-compliant issues, right? And so the whole goal of this is to show that by designing with ops in mind, you can embed detective controls for your resources. Thus, the outcomes of enabling AWS Service Management Connectors and Management and Governance native services are establishing consistent delivery partners, enabling operational efficiency, enabling self-service, and most of all, enhancing customer satisfaction by giving end users the ability to request, view, and manage AWS products within their familiar tools. It's time to take action. And we would like for you to learn more about our solutions that enable management and governance for your cloud workloads, as well as how these solutions can work with our third-party partners in enabling operational effectiveness, such as what Noble 9 does with service level objectives. This concludes our management and governance in the cloud session. Thank you for your time and have a great day. And have a great day.